client side and the server side. So this is your transparent connection. All right. So with transparent connection, this is transparent. So this is the client side. Okay. Let's put this here. What is the source IP? Okay. Source IP, destination, source IP, source port, destination IP, destination port. Okay, this is from the client side. This is the client side. All right. Now, how about for the server side connection? This is again transparent. Okay. So of course we have a source IP here. We have the source port. We have the destination IP here. We have the destination port. All right. Now let's talk about the client side first. What is the source IP? Correct. This is the client IP. Okay. What is the source port? This is the random port generated by client. Okay. What is the destination IP? What do you think is the destination IP? This is the OCS IP. Correct. Why is it? Why? Because the client is not aware, so the client do not know there is a proxy here, right? So the client destination is the website, and we call it OCS. How about the destination port? What is the destination port? Destination port is, correct, the OCS port 80 or 443. Okay. Now let's take a look at the server side connection. Source IP is the, what do you think? Same, proxy IP. Okay. How about the source port? How about the source port? Again, this is a random port generated by proxy. How about the destination IP? This is the, who do you think this destination IP? Default is, of course, the OCS IP. Now the source IP, default is proxy IP. Okay, this is the default, but actually this can be changed. Right? Now the destination port is, again, the OCS port, either 80 or 443 typically. Right? Now, comparing both of them, what is the difference? Let's compare the explicit and the transparent. What is the difference? Okay, well, if you compare both, the difference is, you see, the client IP is the source port is random. Yes, the difference is, yeah, so I have a question here. The client IP, source IP can be client IP as well. The answer is yes, it can also be a client IP for transparent only. It can also be a client IP for transparent only. Okay? Yes, for that. So the difference is here. As you can see, the source IP is the client IP. Source port is the random port generated by client. It is similar. Destination IP is the difference, right? The destination IP for transparent is the OCS. Why? Because in transparent, the proxy is not aware, or the client is not aware there is a proxy. So hence, the destination is OCS. There's a big difference on that. So you have to know that by heart. Okay? Especially when you create policies, talk about authentication, huge difference. Okay? So on the server side, both of them is the same. The only difference is that in transparent, all right, you have the ability to use the actual user source IP address rather than the proxy IP. It only works for transparent. Okay? So take note of that. Understand that by heart, because you deal with proxy, you need to know exactly the difference between the two. Explicit and transparent, how does it look like with regards to the TCP connection perspective. Particularly good for doing troubleshooting and creating policies. Okay? And understanding how the proxy behaves and how the configuration would look like eventually. So that is the two different client connection methods. Okay? It is the user agent that you have to configure on the client side so that you can use either explicit or transparent. So that is client side. Now how about the physical deployment? So this is the proxy physical deployment. How do you deploy the proxy physically in your network? How? One is inline. Okay? Inline is, what is the use case of this inline? Inline is only used for small office type deployment. Likewise, it is used for testing, POC, all right, proof of concept or testing, lab environment or small office type deployment. Why? Because with inline, you can insert the proxy between the client and the server, so it is in the path of the traffic. It sees all the traffic immediately. With this, you can in fact do transparent. This is used for transparent. Can we do explicit? Yes, you can also. How? We just point the client browser to the proxy. It becomes explicit. Okay? That is why it is used for testing, right? Small office deployment, because you can achieve explicit and transparent. For small office, typically you don't have authentication configured in other complex environment. You can just put the proxy in between the client. You need not to touch the client. The client will then pass traffic to the proxy. Proxy will just handle that connection. Okay? So that is inline. Small office deployment, testing, or lab environment. Okay? Primarily used for transparent. Excuse me. Next one, virtually inline. So virtually inline, this one is, what is the use case of this first? So if you are going to deploy a proxy in a transparent client connection method, transparent, okay, in a large deployment, you will consider using virtually inline. But why is that so? Because in virtually inline, the proxy do not sit in the path of the traffic. In virtually inline, only thing is that the disadvantage is you need third-party device, such as router that will support WCP or PVR. If not, layer 4 switch. What will this guy do? What will these devices do then? These devices will then direct the traffic to the proxy. So these devices have feature to direct the traffic to the web proxy. So you can do load balancing here. That's why it's recommended for large deployment, because you can have multiple proxy in load balance environment in transparent mode. Okay? So this is virtually inline. The proxy is not really sitting in line. There is third-party device here that actually directs the traffic to the proxy. So the client need not to be configured. When the traffic passes to this third-party device, these devices, router or layer 4 switch, determine that the traffic is web. It will then send it to the proxy that is configured to connect to it. Okay? So the client need not to be configured. right? So, but it requires third-party device to do that. Otherwise, you use inline. But inline primarily is for small deployment because, as you can see, with inline, you have no load balance here. Single point of failure also. You need to break the traffic and insert a proxy. But with virtually inline, no need. I will maintain one of the proxy. I'll just remove it from the load balance or from the WCP or PBR rotation. Then I can just maintain this proxy. I can add new proxy without even breaking the traffic. Okay? Another one, or the last one, is the out of path. So what is this out of path? Out of path, the proxy is sitting in a switch network environment. There is no load balancer. There is no router here. So in a switch environment, this layer 2, the user, because if you use transparent, if the user is not configured to connect to the proxy, what is the user traffic path? It will just go to the switch, router, in internet, bypassing the proxy, right? So in out of path, it requires that the user browser has to be configured to connect to the proxy. So out of path is primarily used for explicit proxy deployment. Okay, so you point the user browser to the proxy IP, proxy hostname. Or if you want to have load balance redundant, you can just put a load balancer here and then point the user configuration to the load balancer virtual IP. Load balancer will just load balance traffic to multiple proxy. So if you have multiple proxy, put load balancer here, you can achieve explicit deployment. Okay? So that is explicit. If you don't have a load balancer, you can use like, DNS round robin. You can do that. Or the proxy also can perform a active standby without load balancer, right? Active standby. So with two proxy, you can create a VIP, a virtual IP. The browser will hit the VIP, okay, and then active standby. Yes. So if you have a load balancer here, then if you have a single load balancer, you have a single point of failure. Yes. Also, you have a single point of failure if you have only single load balancer. Right? But if you're really concerned about redundancy, you can have multiple also, right? But load balancer are devices that operate in a lower OSI layer, which is, let's say, layer 4. So the likelihood of them failing is not at the proxy, because the proxy is a layer 7 device, right? Because the LFC is an application device. So if you want to have more redundancy, you can put multiple proxy also, multiple load balancers. It's really up to your resources. Okay? Excuse me. So that is the different physical deployment. So in most cases, if you're using explicit, you would want to consider out of path. If you want to use transparent, then you would want to consider virtually inline. Okay? So that is the physical deployment. So knowing earlier the TCP connection between explicit and transparent, however is the proxy configured, physically you know exactly what is the TCP connection would look like based on what we have understood already earlier. All right? Now, another one, besides the physical deployment and the client connection method, the proxy also can have multiple roles. Okay? Proxy can have multiple roles. When you say role, okay, this is the role that the proxy will act in the network. Like, for example, as an employee, you can have multiple roles. So maybe you are also a network guy as one part of your role, or a part of your role, you can also be a security guy, network security guy. So you have two roles, right? You have network role, and then you have a security role as part of your job description. Now, the proxy also has multiple roles. So the proxy can be what we call forward proxy. Okay? When you say forward proxy, like so here, this is the most common deployment of the proxy, a forward proxy, which means to say that your corporate network owns a proxy that secures your web traffic. Forward proxy, most typical deployment of proxy. Another role of the proxy, it can be used as a reverse proxy. So when you say reverse, this time, the proxy is protecting your website. In forward proxy, you are protecting your user against websites at the internet. That is forward, very common role of the proxy. In reverse, you are protecting your own website. In this case, the internet user will hit your proxy only, and the proxy will connect to your web server back to the client. So the client or the internet user will not connect to your server directly. It connects to the proxy only. So this is what we call reverse. Okay? All right. So we'll take a break, and then we continue. Let's say 15 minutes break. So wherever you are in the world, just add 15 minutes. I will stop the sharing for now. So we have 15 minutes break. Just add 15 minutes to your clock wherever you are. Okay, so I'm not sure where are you from, what time zone. I can see that we have multiple time zones here. Just add 15 minutes to your clock, and then we will continue. Okay? So break starts now.